Good afternoon. We're gathered here today to celebrate the life of Gabriel Popescu. This is, for your information, this is being live streamed and recorded. The focus will not be on his spectacular contributions to science and engineering, although there were many, but on Gabby as a person in relation to family, students, and colleagues. It's been only a little more than 3 months since his tragic death, and it's still a shock. Let us all pause for a minute of silence in order for us to recall our best memories of Gabby. Thank you. So many family members and students of Gabby are here today, including his wife, Catherine Best Popescu, children Sophia and Soreen, Gabby's mom, Maria Popescu, Gabby's niece, Wyoming McGinn, Gabby's nephew, Canon Clay Steffen, sister-in-laws, Sherry Saw and Melanie Best, parents-in-laws, Michael Best and Jane Humphreys, uncle-in-law, Rick Best. Gabby's graduate students, Michael Fanu, Neha Goswami, Young Jae Lee, Masa Sankakuri, Jinfeng Zhang, and Young Li Zhao. I had the pleasure of meeting Gabby when, as a chair of the ECE Faculty Search Committee, I helped interview him in 2007. From the start, his strong sense of humor and easy mannerisms came through. He always lived in the moment with a warm honesty and offered insightful comments without regard to conventional thinking. Last February, Gabby was invested as the William L. Everett Professor of Electrical and Computer Engineering. In a speech, he described the way he ran his research group similar to creating jazz or blues. He and students would simply riff on research ideas and occasionally come up with a song. He also described at length how he came to meet and know Catherine Best Popescu, his wife, through studying the effects of drinking alcohol on blood. I'd now like to invite Catherine to the podium to share some of her memories of Gabby.
So Gabby was messing with my PowerPoint today when I was going over it. You said I was always late. You're fine. So the title of my talk was Remembering Gabby. Remembering Gabby is a little bit like foraging for a path through the nightmare of our lives. But I'll tell you, Gabby was always happy, and he was larger than life in a lot of ways. I met Gabby in, I hope it was 2004. And it's true, I was studying the effects of fatty acid esters on red blood cells. And I had hit a wall. There was nobody, no techniques that I could use that could measure the objectively or quantifiably. We couldn't measure the membrane effects or the biophysical effects on red blood cell membranes or any membranes. I was only looking at red blood cells because I was interested in neurons. So I was sending red blood cells through solid phase extraction columns and timing the red blood cells as they went through as a measure. Other people were using tweezers to pull them apart, or AFM, which you have to fix the red blood cells. I was looking for a Jane Goddard approach. I wanted something more physiological. So I went to there was a seminar, I was at MGH, and Cameron was giving a talk. Yep, perfect. There he is. So it'll be a little tough for us. but it's okay, sorry. So this is what I was talking about. So the techniques that were available at the time were very harsh. They weren't, to me, measuring necessarily what's normally found in a red blood cell. So I went to a talk, and it was Dr. Baragzan, that's his name, was giving a talk on lipid rafts. And at the very end of his talk, there was a little, I think it was black and white, or my memory is black and white, there was a little tiny movie, and there was fluctuating, it was just, and Cameron said, Gabriel Popescu at MIT can measure nanoscale fluctuations in membranes. And I said, woohoo, this is gonna solve my problem. So I ran up to the second floor, ran to the lab, sent out an email. Hope my emails are there. So I said, let's collaborate. I have a perfect problem. I think you have my solution. Let's do it. So he says, oh, we're fixing the instrument. It's running kind of slow. Get back in touch with me in 3 months. 3 months, oh my God. 3 months seems like an eternity, but it's okay. I waited. That's what he says, a couple of months, but he was fixing his instrument. So then I thought I emailed him right away, but it turns out, and before, he got my name wrong. He spelled it with a K. But this time he got it right. And this time he said, if you're still interested, if your group is still interested, come over and come give a presentation in the journal club. So just like I'd hit a wall, their group had kind of hit a wall. They couldn't get the red blood cells to live. So the red blood cells were dying. So that's such an easy, simple thing for a biologist to fix. Anybody could have fixed it. But I was lucky because I was there. So from that moment, it was love at first sight. Not between Gabby and I necessarily, but we both saw the same thing. We saw eye to eye. We spoke different languages. Gabby spoke physics, and I was a lipid biochemist, which I kind of cringe to say. But we saw eye to eye. We both saw the power of Gabby's technique. We both felt that Darwin said that nature happens. He said it didn't happen in leaps. He said not jumps, something like this. But nature doesn't happen in great leaps, and neither does science. But when I was working with Gabby's Hilbert phase microscopy, I thought, this is a leap. But my wildest dreams couldn't have hoped for what he could unleash. Being able to measure things without adding dyes, without touching them, and just being able to observe them but quantify them, it was revolutionary, and it was so exciting. So we were both in it. We were inside the microscope all the time. And I could describe it to you, but I think it's better if he does. This was a movie he made, one of his first movies way back then, and he called it Dancing with the Cells. You have to hear it. Oh, please. my name there. So this is where nature does nothing and jumps, but we really felt like this was a major leap forward. And so he said it was a good collaboration with MGH because we were married. And he always said that we were married after several of our publications. So then, I'm going to jump forward a little bit. When Gabby was taking a sabbatical this last summer, he was in Paris. And Sophia and Serena and I joined him a little later. So first we were in Paris, and then we went to Prundu, Romania, his hometown. And when we got there, he'd built his mom a house. It was a beautiful house. And people would say to me, how did he build that house so fast? Remotely. He had cameras. He put out a fire remotely. And the truth is, Gabby never did anything fast. He'd been planning that house since he was in high school. And it was like he was just a very thoughtful person. So nothing was ever rushed. So he took me around the house and he was watching my face to see how I liked it or didn't like it or what I was thinking. Well, first off, I thought it was magnificent. It was unbelievable. Well, we get up to the veranda, which is essentially, it's a porch, and it's up one level, but it's a high level. And we're looking out, and it's absolutely beautiful. And Gabby says to me that he imagined me on the veranda, relaxing, sunbathing. And I was like, me? Sunbathing? Relaxing? And so then he was like, oh, no. If the kids are in trouble. So he was imagining I was relaxing on this up above, and he was in his foreshore, which is that structure there, and inside there's a brick oven pizza place. He thought he was going to be there with his high school friends party. The kids were going to be in this massive pool that he had, and I would be relaxing. So then when I was making a face, he said, oh, no, you can just run across this roof, jump over to the other roof, and you can either jump into the pool, to say them, or reverse parkway or something down the side, and then it'll be fine. So Gabby was both a dreamer and a realist. So that was his vision for the house. He drew hand drawings. He designed it. Again, everything he did was meticulous and well planned, well in advance. So as we were standing there and looking out, I said to him, oh my gosh, I cannot wait for a storm to come. This is going to be so magnificent. Then his eyes were glistening. He gave me the sweetest, kindest, biggest smile. And I think it's because I imagined something he didn't think of. And I think he thought of everything he thought. So, as my friend says, in the most absolute terms, Gabby was the most intelligent person and the kindest person that I'll ever meet. But I think every single memory that any of the kids and I have of Gabby is just perfect. And that's what gets us through. That's it.
Hello there, my old friend. Not so long ago, it was till the end. We played outside in the pouring rain. On our way up the road, we started over again. You're living our dreams, oh, you on top. My mind is aching, Lord, it won't stop. That's how it's happened, living life by the drop. Up and down that road in our worn-out shoes, talking about good things and singing the blues. You went your way and I stayed behind. We both knew it was just a matter of time. Living our dreams, oh, you on top. My mind is aching, Lord, it won't stop. That's how it happens, living life by the drop. train us a means to an end. God, it's good to be here walking together, my friend. Living a dream. My mind stopped aching. That's how it happened, living life by the drop. That's how it happened, living life by the drop. That's how it happened, living life by the drop.
Next, Stephen Bopart, Granger Distinguished Chair of Engineering, will make some comments.
If you want, you can use the collector if you want. Okay. And we'll just forward it and jump to yours. Your slide will be on there.
So this past summer, we lost a colleague, a collaborator, a brilliant scientist, and a true friend. I want to start by offering my deepest condolences to Catherine, to Sophia, Soreen, to Maria, and all your family and friends. Gabby was one of those rare individuals who could really light up a room with his presence, with his candor, with his infectious personality, and his contagious laughter. He would also light up a room just with his intellectual brilliance and insights into not only our shared field of biophotonics and biomedical optics, but also with history, with music, and with worldwide issues that absolutely needed more thought behind them. He was an internationally recognized scholar, the driver of excellence, committed mentor to his students, to his postdocs, to his researchers, and truly a thought leader, all while being grounded in his family, in living life, in making friends, and to never stop exploring. So in my brief comments today, I really want to focus on maybe some of the technical contributions he made to our field that I shared with him, to the impact that he really made, and to the long-lasting legacy that he leaves behind. So just for some background information here, he was born in Romania, as Catherine was also sharing. He received his bachelor's and master's in physics from the University of Bucharest, his master's and PhD then at CREO, or here in the States, before doing a postdoc at MIT. Soon after that, he started here as a faculty member, as assistant professor, then associate, then full, and it was really my privilege to help recruit him here, to work with him as a colleague, and to share many, many, many insights. He built an incredible lab, but he leaves such a legacy. Upon hearing of his tragic death, Bruce Tromberg, the director of the National Institutes for Biomedical Imaging and Bioengineering, said that this is such a terrible and tragic loss. Gabby brought people together with a brilliant technical vision and adventuresome spirit. He was an inspiration and truly a bright light for our biophotonics community. Gabby also recognized that his ideas, to make them truly impactful and to get them out of his lab, and he had to drive that forward too. And he was an entrepreneur. He founded company Phi Optics, and the board of directors there said that Gabby was not only this well-known scientist, but really a visionary leader, and successfully launched this company and brought his ideas to market for greater impact. And now worldwide, people are using his technologies, his instruments to push the frontiers of research and drug discovery and treatments. And while he was a phenomenal scientist, he was an even better colleague in person. His passion for learning, knowledge, and improvement just became one of the core principles of Phi Optics, and he'll be greatly missed. He truly was this internationally recognized researcher and thought leader. He wrote a book in 2011 that really established this whole field of quantitative phase imaging and cells and tissues. He edited another, and he was in fact in the progress of working on a new 10-volume series. He just had so much to offer. And you can see here just the many kind of academic contributions, scholarly contributions he made to our field. not only founding the company, but also just being a leader and establishing new conferences at our national, international conferences, dedicating service to his professional societies, and was recognized as a fellow and by many, many awards, and this is just a small subset of that. His lab, this quantitative imaging laboratory here at Beckman, was really at the forefront, and as Catherine had mentioned too, this ability to use light to image cells and tissues without adding any dyes or stains is just revolutionary, and being able to look at life at the cellular, molecular level without perturbing it, as we do, and was just kind of reflective of just the insight and the impact that he had. Some of his inventions, his discoveries, one was the spatial light interference microscopy, again, being able to view life in action without having to perturb it in any way. And when shown here is a neuron, and being able to watch things happening in these cells and how they interact, and again, view light with life with light. And he applied this thinking about human health too. He was able to use this phase imaging to look at collagen within tissues, breast cancer tissues and tumor tissues, and be able to look at how those change and how those might be used for diagnosis or to inform patients on what might be the best treatment. He invented and looked at this harmonic optical tomography of nonlinear structures, and you think of CAT scans or CTs as tomography, and imagine doing that really at the cellular scale and being able to probe with nonlinear optics, new ways, new molecules and structures that are there, and create these 3D volumes. Truly insightful. And so this quantitative phase imaging that he developed just had this, it was so enabling. It just changed the world. It allowed us to image these tumor cells. It allowed us to image neurons and how they interact. It was useful in materials like chips, and just being able to, again, used for diagnostic structures. And one of the most recent work that he was in progress and really developing further is shown here, collaborating, of course, with Catherine and Rashid and many others here, but using this technique to be able to identify viruses, detect them, classify them. And we all know kind of how impactful that is. And this is, I think, a technology that we hope will continue and still really change the world in which we live. Overall, Gabby was worldly. Wherever he went, he made friends, he made collaborators, he established collaborations, and I think it was his personality and just his zest that allowed him to form these bonds behind science, around science, but at a very personal level as well. He traveled everywhere, but he always came back home, and he was always here calling this our home, his home. Just last February, he was invested as the Everett Distinguished Professor in Electrical and Computer Engineering, and I think we all recognize the impact, but he was so humble as well, knowing that while being recognized here, but also recognized the world around, the world over. I had the privilege of working with him very closely over the last couple of years, also with Mark Anastasio and Rohit and many others, about how these ideas could really be made more impactful and shared. And so for many years, we put together a proposal to NIH, to NIBIB, called the Center for Label-Free Imaging and Multiscale Biophotonics. And he liked the acronym CLIMB because it was so symbolic of so much of what we do. And after a submission, a resubmission, this application received a perfect score of 10. And just within days, it was to be announced within days of his passing that this was to be funded. And following his tragic death, we spoke with NIH. We communicated very closely with the program officer, Dr. Shebastari, and worked collaboratively, and we restructured this really as a tribute to what Gabby started here. And we were fortunate that NIH agreed to fund it, to continue. And in fact, maybe it's a bit serendipitous, but today is the very day that this center starts. This, I think, is think this is just a testament. It's Gabby's legacy to the scientific community. He brought together so many people, 3 technology research projects, 8 collaborative research projects, 8 service projects. You can see all the different ways these are connected, and all the different institutions here in the United States and outside, and all the areas of expertise. But this is what Gabby did. This is what he was so good at, being able to bring so many people together across disciplines, across ideas, and do something great. I found this, one of the slides that he had shared with us through this whole process, and he emphasized this power of imaging with phase, not power. And I think that's symbolic. But I also found this quote that was on one of his slides that I think is just so fitting here. "'Tis such a long way to the star rising above our shore. It took its light to come this far, thousands of years and more. It may have long died on its way, but into the distant blue, and only now appears its ray to shine for us as true." So Gabby, the light you lit for us will forever be our beacon, and you will always be our star. Thank you.
Next, I'd like to invite Rashid Bashir, Dean and Granger Distinguished Chair of Engineering.
Good afternoon. Thank you all for being here. I'm really honored to be here today and to speak about my dear friend and colleague Gabby. I think it's been really very hard for a lot of us because this was just such a tragedy and such an unexpected, of course, the way it happened. I remember when Catherine called me on her way coming back and then turning back around. So my sympathy go out to Gabby's wife, Catherine Popesco, the children, Sophia and Soren, and his mother who's here. So we've known them for a long time. My daughter actually is the same age as Sophia and the name Sophia, and so our deepest condolences, and you guys will always be in our hearts forever. Gabby actually started here the same year as that I did, in 2007. I came from Purdue, and Gabby was here also in 2007. He came here. I remember meeting him really early on, and it was quite interesting because he talked about label-free imaging, and I, from the very beginning, saw him as somebody who was just so, didn't need a label. He was just so, just whatever on his mind, he was there. There was no fluorophore, there was no quantum dot needed to amplify and talk about what he wanted to do, what he wanted to talk about. He was just real, he was so real. And I remember that distinctly, that it was interesting that just struck with me from the very beginning about him. I'll go off script here. There was so I had a technique to measure cell mass using these silicon cantilevers. Tahir remembers that work, and I was so excited about this technique, and I actually went to Gabby and said, "Hey, your imaging method is needed to sort of validate this, and this is going to be better." So he said, "Okay, absolutely, sure, sounds good." And we were on that paper together in PNAS that cited a lot. And turns out that obviously soon after, he blew that technique out of the water by measuring the mass of a cell, of a dry cell, using a label-free method. The cantilever, the work of a few other colleagues at MIT, and our work is pretty much, I would say, not relevant anymore, seriously, because this approach basically took all of it, blew it away. So, and he was very kind to actually get me included in that work and asked me to write a section on that paper, which I did, about the technique that didn't work. But and then we also ended up writing a short sort of perspective together about ways to measure cell mass, which again so I think just the idea that he was so open and sort of collaborative and still recognize all the other work, but then, you know, very humbly brought up what he was doing, which was really the best. So Gabby was really a scientific giant, I think, as Steve just talked about. I won't say a whole lot. He was really a scientific giant. And I think what, again, perhaps not a positive, but what gives me also comfort and calm is, I think I use something that Catherine told me, is that he was the happiest when this all happened. We had just invested him on February 22nd, the spring, with William Everett. This is Dean Everett. The building is named after him, so there was that professorship, very, very prestigious. And he had worked for 2 years. I remember actually talking to him about this P41, that you got to go after this P41. There's none in label-free imaging. And he worked for 2 years and kept at it. And that was just happened. And the house was just built. And so anyway, but that's life. And I think it's just another reminder for all of us that please, hug those you love and know, and spend the time with people you know now, because you never know what will happen. You just never know. There was just some months ago that we were celebrating him right here. He had a phenomenal impact on many of us, actually, with our work in the last 10 years. So Tahir, Martha, June, we worked for so many years and have published so many papers together. I have like over 10 papers with Gabby. And so when I came here, we put all of us working together. We put a NSF IGERT that Gabby was a part of, an integral part of characterizing and measuring cell. We put an NIH training grant. He was a part of that. And then, of course, with our NSF STC EBICS with MIT and Georgia Tech, which really changed many of our careers, I think, over the last 10 years. And Gabby was an integral part of that. So I've just spent so much time with him over the years, and he was such a close collaborator. But I always had this feeling that I hadn't spent enough time with him. I played ping pong with him a few times. He was an avid, very passionate ping pong player. I can't remember who beat who, but we won't go there. But anyway, there was so much that I think many of us did, and I also spent time with him. So it was really just a dear friend. If I think of words about Gabby, I mean, he was fun. He was relentless. He was hardworking. A can-do attitude, and of course, just a very, very deep scholar in his field. But always very humble, always, wanting to discuss and talk about the work. So, Gabby left his mark on history. I think he's at this young age even did amazing things that I think though his work will be cited for a long, long time to come. He was now, just I would say more in the last few years, internationally recognized as the person pushing the frontiers of label-free imaging. So in a way, that's just, there was so much more that could have been done, but that's what it is. So he was just at the peak of everything that he was doing. So I also want to take this time to sort of let everyone know that we're really very delighted that we're going to be able to just all of us together from the campus, College of Engineering, Department of Electrical and Computer Engineering, Bioengineering, Beckman Institute, will be together planting a tree in his honor on campus, and actually very close to this area. The exact site is not identified yet, but we'll be working with the leadership of Beckman and EC to see where is the best place to plant a tree in his honor. That will be here on campus, and a plaque to go with it. So that's something we actually just recently got approved. So very fitting. I was hoping we'll find that out before this event. So I'm really happy to announce that too, that we'll remember him that way on campus for decades to come. He really shaped and touched the lives of so many colleagues, students during his time here at the Granger College of Engineering, and again, many of who are here, and also they've gone on and set up their own successful careers. And again, for those of us who had the honor of serving alongside him as our faculty staff, I mean, he really taught us many things, inside and outside the lab, as has been already mentioned. And in light of his passing, again, we'll continue to hold in our hearts his sense of curiosity, adventure, drive to serve others, just attitude of just this collaboration without any labels, label-free, I remember him that just again, him as being so label-free. Again, this collaboration over self-interest. He was always extremely collaborative and never really sort of self-interest, demonstrated self-interest. And also resilience in again, the face of just keep pushing the field forward. So I think I, for one, will always carry Gabby's light, his light as in, photons, light, his can-do attitude and his ability to use wit and humor to lighten up life, especially life in the lab, life at work. And again, it's people like that make a place, and a place that makes the people. And I think Gabby was just such an integral part of our college and our campus here. He will always be remembered. And so may you rest in peace, my dear friend and colleague, Gabby Popescu. Thank you.
Next, we'll hear from Martha Gillette, Neuroscience Program Director, Cell and Developmental Biology Alumni Professor.
Yeah,
As soon as you start. Yep.
perfect. Well, it is just an honor to have been asked to speak for the many collaborators of Gabby Popescu. You already sense from the speakers who've become before me the impact Gabby has made and his just effervescence and approach to research. I am not an engineer, and I think maybe that's why they asked me to speak today. I am a neuroscientist primarily. And I happened to go to a seminar where Gabby was presenting his work, and I went, oh my gosh, he has a way to look at living cells without interfering with them other than shining light on them. What an amazing opportunity that would be. And so I think I sent some students over, of course, to talk to him about it. But that was the beginning of an amazing collaborative 15 years. I went back, and that was our first paper, so it must have been longer than 15 years that we collaborated. How many collaborators are in the audience today? Raise your hands. I mean, look around. He just touched so many different, and these are all, really big names and big productive areas of science that are spread across the campus, especially this part of campus. So I have got the wonderful thing about students is that they're very inquisitive and they're willing to take risks with new opportunities, most of them are. And so I sent them down to the Beckman, I wasn't here in those days, to see what was happening. And the next few years were amazing and magical. I have some slides, but let me just tell you that the day that Rashid sent the message, he got the call from Catherine and sent the message, was a glorious summer day here. And I'm like, I cannot believe this. Of all the people I know, and I have many dear friends and colleagues there, Gabby was the most positive, vibrant, effervescent individual. And I just remember that day when it was bright and sunny outside and this light of many of our lives was taken from us. And my sincere condolences to Catherine, who gave an amazing talk. Thank you, Catherine. And to Sophia and Sorin and his mother for sharing Gabby with us. I mean, we will not forget Gabby. Now let me just go ahead here. This is meant for me to expound upon light and what it does for us. And what some of you don't know is that light is part of my research program too. How light adjusts you to what you do in the daytime and what you do at night. And so I think it's fitting to think of Gabby as sort of a luminous presence in our lives. Now, Steve mentioned Bruce Stromberg's quotation that Gabby brought people together with brilliant vision, technical vision, and adventuresome spirit. You hear the same thing from all of us. That is Gabby Popescu. Technical vision and venturesome spirit. There are very few collaborators who will take what you're working on and then turn things over and apply it to your specific interests and problems. And that's what Gabby was brilliant at. Very, very comfortable moving into new areas. And truly a bright light of our photonics community. And I realized that, of course, all of this is true, But it's much more than that. Gabby's reach extended to cell and tissue biology, neuroscience, embryology, virology, which means it can impact understanding in a vast array of living systems with real-time dynamic observations and measures. Those are the hardest to make in living systems. And here is a way in which we can look at what the cells and tissues are doing in real time. I want to just give you a sample of one of the studies that we did. It happened to be published within a few days of Gabby's death. And it was using an evolution of spatial light interference microscopy, which was used for cells, and many of the examples you saw today are individual cells from your body. But this was to then go into tissues. And I was actually kind of dubious. I mean, you can see things really clearly in cells with lights in lots of ways. But now we're going into something that's many cells thick and asking it to give you the same kind of report without interfering with it more than with light. And I guess I didn't appreciate how brilliant Gabby was when he brought this to me. But in fact, that's what we did. And we looked at a slice of the part of your brain that forms memories and also loses them. It gets a lot of attention, the hippocampus. So people focus on the hippocampus. And in this case, we're looking at a slice of brain and we're looking at structural changes that the light is revealing. And you can all see this round structure here. And we then coupled it with staining for something that will mark that cell, which is here. And when we overlay them, we can look at this structure, which is a single cell, which is basically, we can then follow. And we looked between, over the course of the day and night, and what we saw was that the structure of this cell changed remarkably. So it swelled and shrunk over 24 hours, not rapidly, but over the day-night cycle, which has an amazingly extreme influence on the microenvironment in which it lives, on its relationships to other cells. So this was really, really big and exciting news. So Gabby, this was the PhD, part of the PhD of Ghazal, Nassiri Garani, and Mikhail Kandel. And we put this together. It took a while to get it published, but Gabby just was relentless. He said, Martha, we've got to get this out. And it came out last June. Here's the citation. So Gabby is a collaborator, and here I'm speaking for myself, but I think I'm speaking for all of his collaborators. Because what you've already heard is many of us have the same feelings about Gabby. Not only did he bring his extremely interesting techniques that let you do things that you kind of dreamed of doing, but didn't know that you'd ever be able to do, he was exceptionally thoughtful and creative. He wanted to understand what you were working on and then how his thoughts could apply to it. He was very hardworking. I mean, he was here, he worked, I'm sure, and Catherine, you have to tell me, you don't have to tell me now, but after the lecture, I believe he went home every night and wrote a paper or started to work on a paper about what we'd just done that day. Because he was always working at night, and then a couple days later, he started to have the formation of the new story that we were going to publish. He was unfailingly fair. And that isn't common amongst great scientists. He was extremely fair about including everyone who participated in the study, the various labs, and make sure they got the recognition they were due. He was remarkably generous with his time, his ideas, his equipment, his interactions, and he was ever enthusiastic and cheerful. Oh my goodness, there was never a time I saw Gabby where he wasn't enthusiastic and cheerful. How many of us interact with people like that every day? I think it's a rare person, and that's why I say his light is with us. Now, Gabby has and had many collaborators, and yet he advanced multiple research thrusts. This is not easy to do, to interact with. I saw Rohit's hand go up in the cancer domain, and I see Hee Jung is here who works on epilepsy, and Mark is here who works on structure. And there are many others of you. Tahir has very interesting interactions building micro machines. All of these he interacted with very effectively. Not easy to do when you're running a lab and doing all the other things you do. And so he advanced all these thrusts and was extremely productive. I counted this up for a recent grant we were putting in, and papers collaborating just with Gabby and I and our labs, we published 15 papers in 15 years. 15 papers in 15 years, that is just unbelievable when I look back at it. He was an outstanding grantsman. We shared many grants. One of the first Brain Awards, which are they're still ongoing, new initiatives to look at the brain dynamically, perfect for what Gabby does. We got one of the first ones on campus. We shared grants from the National Science Foundation, the National Institutes of Health, and then multiple PI, Principal Investigator Awards, where many people got together, put their ideas together, and many of those were funded and were very, very productive and really helped distinguish Illinois as a research powerhouse. And yet he was ever enthusiastic and cheerful. I had to put this down here too, because grant writing is not always associated with being enthusiastic and cheerful. And yet he was, and he was successful. Now, this is a picture that, and I don't know the exact year, but this was from one of the early days of our Science and Technology Center, Emergent Behaviors of Integrated Cellular Systems. What does that mean? It means building small entities out of cells. So it's really sort of microbots, and all of us kind of moved into a new space that we were unfamiliar with. This grant lasted 12 years. It just closed. Rashid and I were both the campus regulators, and just, I think last month was the end of it. Here we have Gabby, of course, June Kong from Chemical and Biomolecular Engineering. Must have been October because of the way I dress. Tahir Saif from Mechanical Engineering. Roger Kam was the PI of this grant. He is a very renowned bioengineer from MIT. He was just here last week to speak in our training grant. And then Rashid, whom you all know. And, oh my gosh, Carrie. And she was one of the first managers of this grant. And then she was recruited away to Merced. So that's why I know it was in the early days of this grant. So that was an amazing award. And all of us grew from our interactions with MIT, Georgia Tech, at least 10 minority-serving institutions. It was remarkable, and we have to put our heads together and think of another way to achieve something like that. And then we have our NSF Graduate Training Grant, which is now already in its 5th year. It seems almost believable. Training the next generation of researchers in biofabrication and deciphering miniature brain machinery. And here's Gabby, here's June Kong. Jorge Maldonado is a student of Catherine's, and he also worked with Gabby. And here's Mikhail Kandel, who worked on the GLIM study that I told you about. These are people from my lab. But these people were part of that training grant. So, the next time June comes, and it's a bright sunny day, go outside and just look out at the fields and think about Gabby Popescu and all of the amazing ways he impacted your lives. He certainly did mine. Thank you, Gabby.
Yeah, G is good.
Sweet Home Chicago. Oh, this is the G we did earlier. Wait.
You can do something new if you want.
Yeah. C major,
C is okay.
E major.
Hello, everybody. I had the privilege of knowing Gabi, excuse me, both from a professional point of view, like many of you, but also from a very personal point of view. We've known each other for about 24 years. We did our work for PhD together about the same time in Orlando, in Florida. And then we continued our friendship ever since. And with Catherine's permission, and with your permission, I'd like to share with you a part of Gabi's life that most of you here don't know. There are just a very few, a small number of friends around here, mostly Romanian, from both Orlando and Boston area. But I'm sure I have a few surprises for most of you. Please enjoy the slides. Thank you. When I find myself in times of trouble, Mother Mary comes to me, speaking words of wisdom, let it be. And in my hour of darkness, she is standing right in front of me, speaking words of wisdom, let it be. Let it be, let it be. Keep up with it. Let it be, let it be. There we go. Hey, and when the broken-hearted people living in the world agree, there will be an answer, let it be. For though they may be pardoned, there is still a chance that they will see. There will be an answer, let it be. Everybody, let it be, let it be. Everybody, let it be, yeah, let it be. There will be an answer, let it be. Let it be, let it be. Let it be, yeah, let it be. Whisper words of wisdom, let it be.
Let it be, let it be, let it be, yeah, let it be. Whisper words of wisdom, let it be.
Good job, everybody. Collaboration.
Is there another musical piece? Catherine's sister? No, okay. Okay. This has been a special opportunity for us to recall and add to our precious memories of Gabby. I'd like to thank all of those who made this event possible, especially Catherine, and Patty Jones, Associate Director of the Beckman Institute, played a large role. Thank you for them. Now I must carry on without Gabby himself. May he continue to inspire us all. Thank you for being here today. Please feel free to continue the celebration during the reception to follow now in the Beckman atrium. Thank you.